Hello, welcome to a new video on Trouble Television. Today we are going to look into how to create a tile map or an isometric tile map in Lerv 2D. The things we're going to look into are applicable to any system that actually works like Lerv, where you have like a canvas-based approach to drawing stuff. So yeah, have fun. Okay, let's start. To have a tile map, we actually need some tiles. So we are going to generate our collection of tiles. There are actually two ways how you could generate the tiles. There is one where you actually have like a two-dimensional array where you first create like the rows and then you insert in each row like the respective tiles in the columns basically. Or you have like a general collection which holds objects in the broader sense which contain an x and y coordinate or like value which can be used as coordinate. And this is actually what we are going to do now. So we're going to create like a tiles table. A table in Lua is basically an array. For x we say we want to count up from 1 through 10. And in the y direction, we actually want to do the same. So in Lua, this is quite easy from like the notation perspective. And then we're going to insert those in the tiles with like the x and y coordinate as a table. We do this as a table because in the future or in the next steps, we actually want to use like a proper data structure which can also hold some functions. So we already start out with the basic definitions that a tile is basically a table which holds an x and y coordinate. We don't see anything right here just yet. So let's start with Love2D. Love2D basically is quite simple to extend. In our case, we only need to extend the draw function for now. The draw function is really just like the draw step. The first thing that needs to be done is we need to clear the current canvas. And what we are going to do after that is we say we want to iterate over all the tiles, which is done that way. And we say, all right, let's set actually the color maybe as well. We're going to set it to red. The set color function accepts 3 values, RGB, and they are actually more related to OpenGL, so that's why we are not putting 255 here, but 1, because 1 is technically like, the full value for red. And after that, we are going to create a points, and we are going to use the tile, the tile X and the tile Y. In this case, I'm actually going to use an offset as well. Actually, we can use it here as well to get a clarity here. Just so you actually see. Actually, maybe do it like that. And if you're going to execute this now, you actually can see that there is like a two-dimensional tile thing that doesn't have any value just yet, but we already can see that our two-dimensional grid is already created. Now that we have our points grid of the tile locations, basically, we need to move on to the next step, which is ordering. You might be aware that most tile map based games have like for the map a kind of diamond shape, which is called diamond ordering. And that's what we're going to do now. I added like a little bit of directory structure here so we actually can see what we're doing step by step. So the first one was creating the tiles. For the second part, we're just copying this code and going to implement the ordering now. Okay, so where we're actually creating the tiles, we just create like a table in line, which is not appropriate anymore since we now need some calculations for the X and Y coordinate before it is drawn. or at a stage where it is drawn. So what we're going to do now is we create a local function which is called tile, which accepts an x and y argument. In there we say there is a t table, which is returned. So this is now basically our constructor for a tile. And in here we actually say that the property tx is x and ty is y. We just renaming them here because it is not possible to have a function and property of the same name, and we want to keep using x and y for the actual coordinates. And then we are going to add some functions to our tile, namely x and y. And to implement the ordering, we just need to do the following. We just say add y to x for the x coordinate and subtract y from the x coordinate for y. And then we are just going to change the call or the construction of our tile to tile xy, which calls the constructor which just also returns like a table, but with some functions appended. And in the actual draw call, we change it to x and y. We actually can see just like a triangle. And the reason for that is, as you could see, that there is actually like, because we are starting from 1 through 10, and yeah, basically the y is always subtracted from the x for y. When, for example, we are still in the x position 1, but in the y position 10, we're actually going into negative numbers. So to fix this issue, there's actually quite a simple way. We are just going to introduce an offset x and offset y attribute to the function as well. We should give them some default values just so if we forget to set them, we actually see something anyway. You can do that by using like the OR notation, which basically says if this function, this attribute is set, or this value, this variable exists, use it, else use the default. And what we are going to do now in the coordinate functions, we are just going to add the respective properties. You actually see like the whole diamond shape. Okay, after ordering now our points for now in diamond shape, which basically translate to a horizontal angle change of the camera or a camera rotation in the horizontal angle of 45 degrees. We also want to add like some depth to the tile map as well, or like a camera rotation in the vertical axis. So yeah, let's start with that. We are just copying the ordering code to have like a proper step separation. And first thing we're going to do is remove our helper parameter down here, because we don't need the offset anymore since we have like a proper calculation in a second. And the second thing we are going to do is we are going to add a width and a height to the tile. I know it's bad practice to add like new attributes in the middle of it, but it makes sense logically, so I'm going to do it anyway. And the third thing we're going to do is introduce like the width and the height of our tile to have like some depth in our x and y calculation. So let's do that. For x, we are going to use the tile width divided by 2. And for the y, we use the height divided by 2. And to set the properties, we are going to set 50 and 25. Why 50 and 25? Well, when the height is the half of the width, it actually translates perfectly to a camera angle of 30 degrees. And this is quite nice because like it's a quite nice round number, and it provides enough depth. So you actually like have some value you can actually like work with later. And we are also going to add like some proper offset and offset y now for the tiles, because when we have like a proper width and height of the tiles, we also need like some calculation to actually center our map in the middle of our game screen. And we're going to do that by using a loft function to help us. We are going to create two new variables, screen width or game width, game height, and they are the result of a function in the graphics package of loft called pixel dimensions. I hope I wrote that right. And here we are going to say, all right, the offset x is game width divided by 2, because that's like the middle point in the x direction, or the middle point. And we want to move it a little bit to the left because we are starting with the leftmost like point or tile to go to the right. So what we're going to do is actually to move the whole map by a half to left to actually center it. And this is done because we have 10 tiles, so 5 times and then the width, which is 50. And for the offset y, we are just going to use game height divided by 2. You will see we actually have like a proper diamond shape, and it kind of starts to look like a map, I think. So yes, maybe actually render the tiles now. Okay, so after preparing now everything we need to draw our tiles, we have our ordering, we have our scaling. Let's get actually to work and draw our tiles. So let's copy our scaling code, or the code of the last step, and get started. All right, so first thing, we are going to add a draw function to our tile. This won't be a simple function, as you can see here with a dot, but we use a function with a colon. Let's call that draw. The reason for that is the difference in Lua between the single dot and the colon is that a colon function by default will have the self parameter. So self in this case actually relates to the table the function is dependent on. So what we can do here is we can actually call x and we can call y, because we need both of them for drawing the tile itself. We keep our points down here because since it is still our middle point, it might be interesting to still be shown, but we're going to copy now the color function and paste it in here and change the color to white. And then we say tile draw down here. So this should actually draw itself kind of. Okay, so to draw the tile, we need to be aware that the tile basically is just a polygon. So we are going to use Loft Graphics Polygon to draw it. We set the mode to fill, and then we need several points. A polygon just accepts basically the x and y coordinates of points with no separation. So we have 4 points. We have the left point with an x-axis. We have the left point with the y-axis, and we have the same thing for top, right, and bottom. And now we actually need to set those points or calculate those points. X and y are the center. So when it comes to the left point, it should be x minus width divided by 2. And when it comes to y, because like the left is on the same height, it should be just self y. For the top point, tx, ty, the x shouldn't change because it is like just above the center, so we should have x. And for y, we have the y minus the height divided by 2. For the right points, we are still on the same. Okay, so first maybe x. So x plus width divided by 2, but we are still on the same y position as the middle point. And for the last one, which is bottom, we are on the same X position as the center, but our Y is moved bottom or down a little bit. So as you can see now, our tiles are drawn. We still have our middle points or our center points or whatever, but we also have like the tile. Let's change it maybe to stroke to see the actual tile like frame. So let's change this value to line. Oh, execute it again. And now you can actually see like our tile map. We have like still the center points, and like for each tile we have like the proper frame. Okay, so after drawing the tile, it might be actually useful to add some interactivity to our tile map as well. So you actually see how you can do that. What we are going to do is implement like a little hover effect. So when the tile is hovered, the polygon is drawn filled, and if not, it is drawn as line, like just like the edges. So let's get started. Let's copy the code of the previous step and paste it for our proper step separation. And yeah, let's start. So first we are going to use another love function, which is called love mouse moved, which will receive the mouse cursor X and Y position. And in this function, we actually want to iterate all tiles and call on each tile check hover, which also receives the MX, MY. This way we actually can implement it within like the tile to actually check for its hover and don't need to figure out how we actually pull each value out of it. So let's declare the function up here. Let's call it t check hover mx my. And to actually have like a state that is checkable or usable, we're actually going to add a state variable in the default or in the start table. Let's call it hovered, which is false by default. And then we need something where we can say self hovered equals point in polygon or something. I'm just going to use a placeholder right here because actually it is kind of complicated to explain how to write a function that does a check if a point is within a polygon. There is one proper method which is like called, I think, the raycasting method. I wrote like a function a while back that uses the Franklin implementation of that method. So what it does is basically it draws a line through the point you want to check and each vertice after each other, and then based on the numbers of edges it crosses, basically it determines if the point is within or outside the polygon. So I'm just going to use this function. I'm going to make it available on GitHub so you can use it as well, but I'm not going to explain it for simplicity's sake. So first let's actually include the function. Let's say funcs, and we require lib. And then we say in this case funcs we call it, sorry. It is called point in polygon. And here we actually pass in like a list of vertices and a point. The vertices are the polygon, the point is the checkpoint or the test point. The structure is quite simple. Each point just has an X and a Y. Same for the test point. And then we are going to copy the vertices of our polygon we created up here to down here. And then we're just going to fill it LX, LY, TX, TY, RX, RY, and bottom X and bottom Y. And our test point is just MX, MY. So let's save that. And now we have like our state variable. So let's do something with it. Self hovered, then else end. So as declared at the start, if it is not hovered, we are just going to draw a line version of the polygon, so just the edges. And if it is hovered, we actually want to fill it. And as you can see now, you have like a proper hover implemented for your tile map. Okay, so now we actually are finished with our implementation. I hope you learned something or you can use it for something. I might need to create some more videos regarding isometric tile games. Let's see, but thanks for watching. Bye.